Greetings and welcome to this fifth video in the introduction to our series. In this video we will be looking at importing and exporting data into and out of R. We will be looking in particular at importing and exporting CSV files, that is comma separated variables, and we will also be looking at importing files using other formats from other types of software such as SPSS, Stata, and Excel. In order to import these file formats from other commercial software, we will be by necessity drawing on some user-written packages that have been designed to do exactly this. Because R does not come with the functionality of importing such files by default. So starting with the CSV files, the comma-separated variable file format is fairly convenient because it is in plain text format. So this means that you can open a CSV file in a text editor as plain as Notepad and edit it by hand. And you will still be able to import it to any of the commonly used statistical software such as SPSS, Stata, etc. It is also convenient in the sense that all the commonly used software packages can import, that is, load and export .csv file. So for this reason you can consider the CSV file format as a cross-platform or platform-free data format. Now the drawback of the .csv format is that it does not retain the more exotic types of data structure types when you store it. In particular, the factor variable type will be stored in a CSV file as a character string. So the levels and the ordering of the factor variables will not be retained when you save data as a .csv file. And conversely, the upside of the .csv format is that anyone can basically open it in whatever type of statistical program that they want to be using. Now the .csv format can be imported into R by using the Read Csv function. And you see here this drop-down menu here that there are actually two read.csv formats or functions, where the difference between these two is basically with the default values that are supplied to the arguments of the functions. So we will primarily be focusing on this .csv format and basically be ignoring this CSV2 function. Now the first argument of the read.csv function is the file that you are to be importing. That is the CSV file that will be read by R, and if you assign the whatever this function here retrieves, it stores the file inside a new object, and if you don't assign it to anything, then it will simply print the data out as into the console. Now if the file that you want to be importing is not located in your working directory, then the location of the file has to be included as part of the file argument. So you can set the working directory quite simply by going up into this session tab here and choose the set working directory option and choose directory. You can see what is your current working directory by looking at the console window here. But if you do not, you can also see what kind of your working environment is by asking R get WD, which stands for get working directory, and you get a printout, a string printout of where you currently are located or where your working directory is currently set. Now in the case here, I will my data is not stored in my working directory for the purposes of illustration. So if I want to see where my data is located, I can ask R to print out what kind of files are located in my working directory by using this dir, that is directory. I can simply run this like this, and you see here I get a string printout of what is located in my working directory. Now I have placed my data inside a folder called data. So if I want to, I can set my working directory to this folder. So set working directory. I can simply copy this here, and I can add the data. And now I set my working directory to my data folder here. And I can see what is located in my data folder again by asking for or providing the dir function. And we see here that I've saved my data folder consists of a number of different data files. So to read then this empty cars.csv data file, I can simply input as the first argument the empty cars.csv here, and you can see that it popped up in my environment stored as data, an object called data. If I print this out here, we can see in the console window the contents of the empty cars.csv file. Now, if the empty cars.csv file was not located in my working directory, I would have to specify further within the string here where to find it. So that's just for the purposes of illustration again. Set my working directory. Now this here works only on Windows computer. If I do this there again. So now I'm back to the old working directory. So if I want then to go into this data folder without choosing to set my working directory to data, I have to include this path here relative to the folder relative to my working directory. And now I loaded the data from another folder than my working directory. The Read.Csv function includes some arguments that are kind of important to go through. So the first argument that we just went through is the file, where you tell R where to locate the file and how it's named. The header argument tells R whether the first line of data within the file includes the names of the variables, or that it's data, that is, the variables are not named, if the variables are not named within the CSV file. So if the first line of data within the CSV file is data and not the names of variables, then you have to specify false to the header argument. The sep argument refers to the separator, that is, how are the variables separated within the CSV file, what tells R that one variable ends or one value ends and another starts. So CSV stands for comma separated variables. So in this case here, the default is set to the comma. However, it does not necessarily have to be the case. It can, for example, be a semicolon, as we see in the Read Csv 2 file or function. The quote argument is not so important, I think, unless something other than standard quotes are used within the file. And the DEC, the decimal places, how are decimals marked, is sometimes specifically for European style notation is separate. Uses a comma instead of the punctuation mark to mark decimal places. So this is why the Read Csv 2 file is often better suited for reading CSV files that have been generated in a European format, and the standard Read Csv file Read Csv function is better suited for reading in files, the CSV files written in standard American notation. So here we have opened the empty cars.csv file in Notepad, so we can see what this looks like in the plain text format. So we see here that in this first line of code here, I have the variable names, and following we have the data, where we see that the comma here is used to separate the values for each variable. So this 4 here corresponds to this carb variable, and this 4 here corresponds to this gear variable, etc. We see that the character strings here, which marks character data, is enclosed in quotes, and that the punctuation marks here are used to note the comma separator, so that this here is then 3.9. So this here then uses notation that conforms to the standard or the default values of the read.csv function. So we can make some changes here to this file to illustrate why the header function is important, or the header argument. So if I now remove this first line of the data file, which includes the variable names, and save it, and I try to read the file again. If I do this then, and I print it to the console, we see here now that the first line of data has actually now been used as variable names and not as data. So I have to include the header argument. Now it's strictly necessary to write out header because it is the second argument, and I can change this to false. And if I do this, you see that this first line of code, or the first line of data, is now appropriately included as data and not as variable names, and R is then automatically given the variables names from V1 through V12. Now if we go back to the data and make some further changes, let's say that we replace all of the commas with semicolons, like this, and save the data. If we now try to read this into R like this, then we get a problem, because we haven't specified that the separator is the semi-comma or the semicolon, and rather than the default comma. So that means that we have to change or provide more information to the separator argument. So we write this. Now we tell R that the separator is changed to semicolon and not comma. So if we do this, then we see once again that it's working as it should. Going back to the CSV file, we can make further changes here. We can change the punctuation points with the commas to mark another, or use another marker for the decimal places. And save it. Go back to R. And run this then. We see now that this includes then a comma, and if we check the class, of Drat or data Drat, we see now that it's imported as a character variable and not a numeric variable as it should be. Now, incidentally, this new dataset now conforms to the default values of the Read Csv function. So now if my data is stored in this new way where I made these changes to the data file, I can remove this here and use the Read Csv argument instead of the standard Read CSV argument, use the default values. So if I do this, we see that the data is imported and it appears as it should. And if I now ask for the class of Drat again, for example, we see that it is now numeric as it should be. So when the data is as this format here, then this conforms with the default values of the Read Csv file or the Read Csv function, which allows you to use it without having to make any further specifications. So that does it for importing CSV files. Now, as for loading other formats such as SPSS and Stata files and Excel files, we have to use some user-written packages. In particular, the packages that we will be using is the Haven package and the Read Excel package. So these can then be installed using the install packages function, and we can right here provide a character vector and provide Haven and Read Excel and do this. Now this might take a moment. So now we have installed these two packages, which allows us to load them. And these two packages then provide a number of different functions that allows for reading files that are stored in commercial software formats. So in particular, this Haven package provides the functions that allow for importing the .sav files and the .dta files, which are used by SPSS and Stata. Respectively, it also allows for importing data from SAS, which some might be using, And this Read Excel package provides functions for reading different file formats associated with Microsoft Excel, such as XLSX files and XLS files. So let us first try to install some or to load some data associated with the SAV file formats. We can, in this case, we use the read underscore, in this case, SPSS function provided by the Haven package, as you can see here. And we simply just, as with the CSV files, we specify the name of the file as well as the location. So in this case, it is exactly as before, data.empty_cars. In this case SAV, which is stored as, and I assign this to a new object which I call my SPSS file. Run this, and we see here that it appears in the global environment. Now if you open this or print it in the console, we see that this is actually included as a table file, which is a tidyverse type of data structure. So these are kind of strange to work with. So I personally prefer to work with data frames, and this tables can be converted into data frames by using the asDataFrame function. And now it is stored as a data frame object rather than a table. So the procedure is exactly the same for example, Stata files. I can do my Stata file here, read Stata, and locate the file. Now Stata stores the data as DTA files. If I read this, print it to the console, we see again that the file is imported as a table, and we can convert this into a data frame as before, print it, and we have now made the object into a data frame, which is more convenient to work with. Now we move on to reading in Microsoft Excel files, the functionality of which is provided by the Read Excel package. The general function for reading in Excel files is the read underscore Excel function, and we can get an overview of how we used it by exiting or entering the help file. So we see here that there are actually three distinct functions here, where you have the dedicated function for reading XLS files and a dedicated function for reading XLSX files. And you also have this general function here, which can be used to import either of these two documents. It intelligently determines what kind of format you are trying to import. So we see here that the read Excel function includes some arguments: path, sheet, range, etc. So I will be only going through these first couple here because they are the most important, I think. So the path argument is basically the same as the file argument, which we know from the Read Csv function. The sheet argument allows you to specify the specific sheet of the Excel sheet that you want to, or the Excel file that you want to import. And the range argument allows you to specify the specific cells that are to be imported if you do not want to import all of the cells. So here I have opened Microsoft Excel, where I have the data stored as the XLSX format. As you can see, it's the same as before. I'm using the European version of Excel, which means that you have the comma used as the delimiter for decimal places. Now if we go back to R, I can import this file using the Read Excel function, as I did with these other functions here. I specify data /empty cars.xlsx, and we see that once again the file has been imported, or will be imported, as a tibble. Now I can store this, for example, as my Excel file, and to immediately convert it to a data frame, I can use I can wrap as data frame around this function call. Run this, print it out, and we see that it's now been imported as a data frame. Now, because the first column was not named here, the Excel, or the importing, came with a warning, basically, where it says that this empty name, which we see in Excel, we see here that this column here did not have a name associated with it. So the Read Excel function automatically assigned a name, in this case .1, to this column of data. Now consider that a case where you do not want to import data from the first Excel sheet, but let's say that you want to import the second sheet into R. You then use the sheet argument. Now in Excel here, you see that under this tab here, I made just some random data, and I can import this into R from the data file if I specify that it is the second sheet that is to be imported using the sheet argument. And here you see that the contents of the second sheet was imported rather than the first sheet, which is what will be imported by default if you do not specify any sheet that is to be selected and imported into R. As for the range argument, if I want to import a limited section or a limited selection of data, for example, if I just want the first two rows and the first two columns of this Excel file, I can specify the rows and the columns that are to be imported. That is, in this case, I want the variable names, and I also want the two first values associated with each of these variables. So that means that I want to import row and column A1 to row and column B3. That is, it starts top left A1 and it ends B3. Now I can specify in the Read Excel function using the range argument that I just want to import a minor subset of this sheet. In this case, I want to specify that the range that I want to import is the variable of the cell A1 through cell B3. And we see then that I imported the first two rows of data plus then of course the first two columns of the row including the variable names. So now we have gone through how to import data using the file formats that are not native, so to speak, to R. R comes with its own file format which it can use to store files, which is the Rdata file format. So this is then particularly well suited for storing R objects. One very useful feature is that it can store entire environments at once into the same file, not just simply individual data frames. The function that is used to import R data files into R differs quite substantially from the convention that is established above, where you have this read point or underscores. That is, you load R data files into R simply by using the load function. Now I have a file under data that is called mtcars.rdata. Now before I load this, I will clear my environment for the purposes of demonstration. If I run this, we see that this data object is imported. That is, I had stored the empty cars dataset in the Rdata file as that's an object called data. So if I then open this, we see that this is then a data frame. Now perhaps important to notice is that you did not have to assign anything in this case. I did not have to assign the output of the load function into any particular object, because it simply imported all the objects that is included in the R data file straight into our global environment. Now a R data file does not have to contain simply a single object. It can contain multiple objects. Indeed, you can save entire environments directly into an R data file. Now in my case, I have an R data file that consists of several objects. Call this my environment. And I can load a file that I've called data/my-environment.rdata. And you see here that the my environment file then consists of these four objects here. That is the data, my Excel file, my SPSS file, my Stata file, etc. That is, I had stored the objects that I created previously here into an Rdata file called my environment. So this is to show you that an Rdata file, one of the really powerful features of the Rdata file is that you can store multiple data frames and indeed any type of vector, function, etc. Everything that is located in your environment you can store into an Rdata file so that you can load your entire R session and save your entire R session into an Rdata file and load it at any point that you want to. So now we have gone through loading data into R, and now we will be going through saving our data into specific files. So now we will get save data. So we can take first things first. We can use the save as Rdata, as we just went through it. Now Rdata or Rdata files can be created using simply the save function. Now the save function tells you first to specify which object that is to be saved. We can say that we want to save data. And then you can specify as part of the file argument what the file is to be called. So for example, mydata.rdata. We can further specify that more objects than just one is to be stored in the file that we are making here by saying data and following up with the additional objects that we are going to be making with the simply specifying the object. So my Excel file, for example, my SPSS file, and my Stata file, Stata. And if we then do this, we can now load. Let's just remove our environment for the purposes of illustration. Now we can load the first that we made is the mydata.rdata. And we see that this shows up here. It was the first object we made. Now we remove this and we load mydata2.rdata. We see that all of the objects that I told it to store was then returned to my environment. Now there is another function in R that makes saving your entire environment quite simple. And that function is save image. And then you simply specify the file. In this case, let's call this mydata3.rdata. And then I do not have to specify which objects to include, it just takes all of them. So if we then, once again, just say load mydata3.rdata, now I just cleaned up my environment here. And if we load this, we see that simply by saying save image or using the function save image and specifying what the name of the file should be, we stored the entire environment without having to specify which objects that should be stored in the file that we made. So moving on to the CSV files, that is saving CSV files. The function for saving data as .csv files is write.csv, which then takes as its first argument the data object that is to be stored. We can take the data file or the data object that we've got stored in our environment here. So we give it data and we provide the file name equals to, and let's call this my CSV data.csv. So now we have stored this as my CSV data.csv, and we can load it again. Let's just remove the data object for the purposes of demonstration. We can load it using the read.csv file. Let's store it as the data here, read.csv, and we want to read the my csvdata.csv file, and it's then stored up here or loaded up here. And if we inspect it, we see here that unfortunately we have an extra variable here, and this is because the write.csv function, unless you specify, it includes the row names unless you tell it explicitly not to. And this, when you then load the CSV file like this, it will then interpret these row names as being a new column. That is a new set of variables. So we can change this. Let's just load the environment once again here, so that the data object is the old one. Now, if I want to make sure that the column or the row names are not included when I store this file here, I have to add the additional argument row names equals false. So if I do this, and once again remove the data file for the purposes of illustration, and read the file again, now I have imported the CSV file, and this time it does not consist of the added variable or the added vector which represented the old row names. So this concludes then the video on exporting and importing data into and out of R.